This is the video for Chem 223, Lab 8, Properties of an Ion Exchange Resin. In this lab, you're provided with a stock solution of sodium hydroxide. The stock solution's concentration is about 0.1 molar, but be sure to note the exact concentration listed on the bottle. You'll be making a 1:5 dilution of the sodium hydroxide standard. You'll do this by taking 5 10 ml aliquots and putting them into a 250 ml volumetric flask. You'll then dilute this solution with water up to the 250 ml gradation line. Now let's grab an ion exchange column from the box and fill it with resin. You'll want to measure out between 1 and 2 grams of the resin, but generally err on the side of more resin than less. You'll then make a slurry with the resin that you can pour into your column. To do this, simply add your resin to a beaker and then add water. It's now time to load the resin into your column. Notice that your column has 3 ports, 1 on the bottom and then 2 on top. We'll start by draining the column. To do this, you need to release at least one of the caps on top and release the cap on the bottom. We'll let this drain until it's about 2 or 3 centimeters from the bottom. To stop the flow of the solution, we can put the cap on the top of the column back on, and then put the cap on the bottom back on. To load the resin, let's remove the big cap from the top, and simply pour the slurry into the column. You'll notice I'm letting the water run the entire time I'm adding these beads. Unlike some other chromatography, it's actually okay to let these resin beads run dry. If you still have beads in your beaker after pouring your slurry into the column, just add more water to the beaker. If you need to store your column in the middle of the experiment, simply fill the column back up with water without removing the resin. Replace the lids and store the column in your drawer. In this lab, you actually get a practice before you start measuring any of your unknowns. You've been provided with a 0.3 molar sodium chloride solution and a 0.1 molar iron nitrate solution. You should be able to calculate the number of protons released from the ion exchange column for each of these analytes, and then compare that with the number you get from your titration with NaOH. We'll start with the sodium chloride. First, you're going to make sure that your column is charged by passing about 10 moles of 1 molar HCl through the column. Notice that I'm using more than 10 mils of hydrochloric acid. You should consider most of the values listed in the lab procedures to be lower limits. Generally, the more acid and water you use for each wash of the column, the better your results will be. You'll next want to wash off any excess acid from the column. You'll do this by running a minimum of about 15 mils of water through the column. The column is now ready for us to use to analyze the sodium chloride solution. Make sure to put a fresh beaker under the column before loading your analyte onto the column. You'll be adding 2 mils of sodium chloride. You'll then rinse the column with 10 mils of water. Once all of the water is eluted off the column, you can take the beaker, add a stir bar and a few drops of phenolphthalein, and then titrate with sodium hydroxide until the solution turns pink. Once you're satisfied with your sodium chloride results, it'll be time to practice with the iron nitrate solution. The procedures here are the same as with the sodium chloride. We'll prep the ion exchange column with hydrochloric acid, rinse off excess acid with water, switch out for a fresh beaker, add 2 mils of the iron nitrate solution, and then rinse the column with more water. And then we'll titrate the eluate from the iron nitrate solution with sodium hydroxide. Once you're feeling comfortable with your results from the sodium chloride and iron nitrate solution, you can go ahead and analyze your magnesium unknown. This will be done in the same way as how you analyze the sodium chloride and iron nitrate solutions, with the exception that you may need to analyze more than 2 mils of your magnesium unknown. Start by analyzing just 2 mils, and then if your titration takes less than 10 mils of NaOH to reach the endpoint, use more of your magnesium unknown for subsequent runs. This does not mean you need to throw the results out that you got for your first analysis. It simply means you'll get better results by using more of your magnesium unknown for future titrations. You'll be analyzing the vanadate sulfate in the same way as well, except for this analysis you'll be using 10 mils of the solution instead of 2. Note that when you use the vanadial sulfate solution, it leaves a blue or green color on the beads. And when you run 10 mils of acid through, it doesn't usually get all of the color off. This is fine. There is still plenty of surface area on the beads for further analysis. And in reality, you never perfectly washed out the sodium chloride, iron nitrate, or magnesium samples from the column. You just weren't able to see them because they're colorless. If we run a lot of acid through, we can ultimately get all of the vanadial sulfate off the column. However, this will take too much acid and is not necessary. When you're done with your titrations, make sure to collect an absorbance spectrum of the vanadial sulfate solution.